This is Module 4, Lesson 20, where we're going to start introducing simultaneous equations. Like the standard says here, the key here is to understand that solutions to a system of two linear equations is the point where the two lines intersect, okay? Because those points of intersection satisfy both equations simultaneously. So what we're going to do here is we're going to write linear equations from graphs. That's a review of what we've been doing. Then we're going to identify the points where those two linear equations intersect, the solution to the system of linear equations. And then from linear equations, we're going to determine whether the lines are intersecting, parallel, or the same line. All this material comes from the packet, pages 3 and 4, and from the Eureka Workbook, Module 4, Lesson 26. Start with, let's get some terms down. Systems of equations. When we're talking about systems of equations, what are we actually talking about? We're talking about, in this case, what we're talking about would be two linear equations. So we're just going to be talking about two linear equations. Now that could be more than two, but for what we're doing right now, what we are talking about is two linear equations, okay? For instance, if we have y is equal to 2x plus 3, and we have y is equal to 5x minus 7, this would be a system of two linear equations that we would be working with. Now, the solution to a system of two linear equations, is the points where the two lines intersect, where they cross. The point that fits on both the lines. Okay? Algebraically, so algebraically, the point, this xy, where they intercept, is where the two equations, what makes both equations equal, okay? Now let's look at this. If we have two lines that are intersecting, there's one point where they intersect. On a coordinate plane, that point can be found at xy. If there's two lines that intersect, there's one solution. What if you have parallel lines? Lines that never intersect, you know, like train tracks. They would never intersect, so there's no solution. What if you have the same line? Let's say you've got this line here, and then you've got the exact same line plotted on top of it. Think about two pieces of spaghetti laying on top of each other. Every point on here would be on both of those lines. Every point on here would be a solution, so you would have an infinite number of solutions. Let's start here. First, let's find the solution for these two linear equations. The solution is simply where these two intersect. And you know how to find the coordinates for this. You start at the origin. Is it 1, 2, 3, 1, 2, 3, 4. The solution is at 3, 4. You have found the solution. Now, this particular thing is asking you to also give them the systems of equations. You can figure out the system of equations here. You can write them. We know how to find a system of equations. Y is equal to mx plus b. B is where we cross the y-axis. So let's start with this red line here. Let's deal with it, okay? That whole line there. Where is it crossing the y-axis? It's crossing the y-axis at 2, so the b is 2. Now we need to find the slope, the m, the rise over the run. You find 2 points that are on this line, and you do rise over run. This is up 2 and over 1, 2, 3. So your slope is 2 over 3. That's the equation for one of the lines. Y is equal to 2/3 x plus 2. We've already done this in other lessons, so this is something you're used to doing, system of equations. Let's find the equation for the other line here, this blue line, okay? If I'm looking for the equation for that line, it's y is equal to mx plus b, right? And we have to find the m and the b. The b is where it crosses the y-axis, which is right here. That's at negative 1, 2, 3, 4, 5, negative 5. And what is our m? Our slope. Let's find two places. This is on grid lines that intersect. Here's one, here's one. This, we're going up 1, 2, 3, and over 1. Our slope, our rise over our run, is 3 over 1. 3 over 1 is just 3. Our equation for that line is y is equal to 3x minus 5. Okay? We found the equations for the system of equations. We found the linear equation for each line. We found the solution, which is where the two lines intersect. Okay? Let's do the same thing here. Let's take care of this line. What is the solution for this system of equations? The solution is where the two lines intersect. I can simply find the coordinates for that point. If you start at your origin and go back here at 1, 2, 3, 4, 5, -5, -2. The solution for these two equations is at -5, -2. That's where those two lines intersect. Okay? Now, they also ask you here to give them the system of equations. That just means to write the linear equation for the two lines. This is just a review of what we've done in the past. Okay? Remember, you start with y is equal to mx plus b. Your b is where the line intercepts the y-axis. This is the y-axis. It intercepts it at 3, so your b is 3. Our m. For our m, we find where we've got 2 point strong grid lines where grid lines intersect. See, this one is and that one is. My slope is up 1 over 1. Remember, our m is rise over run, change in y over change in x. So that's 1 over 1. 1 over 1 is just 1. Y is equal to 1x plus 3. Or you could just simply say y is equal to x plus 3, because 1 times something doesn't change it. Now let's find the linear equation for the other line that's there. Here's this other line. Let's see, we know we start with y is equal to mx plus b. Our b is where? Our b is where this line crosses the y-axis, which is right here. That's at -1, 2, 3, 4. -4. We need to find our m, don't we? Our m is our rise over our run. Here's a point that's on grid lines that intersect. Here's another point that's on grid lines that intersect. My slope would be down 2, so that's down 2, and over 1, 2, 3, 4, 5. Down 2 over 5. My slope is down 2 over 5. Y is equal to -2/5 x minus 4. Okay? That covers, we have shown how to find the linear equations. We have shown how to find the solution, which is simply where the two lines intersect. Go to the next page in your packet. Number 3, it asks us for our solution. Remember, the solution is where the two lines intersect. Okay, let's see. This is at 1, 2, 3, 4, 5, 6, -6, -1, 2, 3, 4, 5, -6, -5. The solution is simply where the two lines intersect. Okay? And oftentimes that's as far as they're going to go in asking you to find a solution. Most of the time they will not ask you to also find the system of equations. This particular worksheet does. So let's find them so we can practice finding the linear equation for lines. If I'm talking about this red line here, okay, remember when we're finding a linear equation, it's y is equal to mx plus b. Where's our b here? Our b is where it crosses the y-axis. That's crossing from the origin, 1, 2, 3, 4, 5, 6, 7. That's 7, okay? Let's find our slope. Our slope, we've got to find 2 points that are on grid lines. Those two are. It's down 2 over 1. Our slope is rise over run. So we're going down 2 over 1. That's -2. This equation is y is equal to -2x plus 7. Okay, let's find the equation for the other line. I'm going to call that the blue line here, okay? A linear equation is y is equal to mx plus b. We need to find the b and the m. The b is where this line crosses the y-axis, which is right here. That's at 1. Okay, now let's find our slope, our rise over our run. We need 2 points that cross grid lines. This is going down 1 and over 1. The slope would be -1. Y is equal to, you can say -1x or -x, doesn't matter. Okay, that's your system of equations. Usually they're not going to ask you to find the system of equations. They'll just ask you to find the solution. Okay, let's look at number 4. What's the solution for this system of equations? See, we've got this line here and this line here. It's where the two lines intersect. What point's that at? Start at your origin. That's -1. Okay, so -1 and up 1, 2, 3, 4, 5, 6, 7. That's -1, 7. Now, let's find the system of equations. If this is my red line, let's find its linear equation. Y is equal to mx plus b. Where's my b? My b's right here, isn't it? Let's see, that's at 2 on the y-axis. My m is my slope. I find 2 points that are on grid lines. Here's another one, and here's one. I'm going down 1, 2, 3, 4, 5, and over 1. That's -5 over 1, or -5. Y is equal to -5x plus 2. Okay, let's do the other one. Y is equal to mx plus b. Okay. In this case, we're talking about a horizontal line. It goes through the y-axis. So it's just simply y is equal to, and where's it going through the y-axis? It's going through it at 1, 2, 3, 4, 5, 6, 7. That's 7. Okay. Now let's look at these two. What's the solution for this one? They don't intersect at all, so there is no solution, right? It's not 0, it's no solution because there's no point where they intersect. They're parallel. Okay, let's find the two equations. Y is equal to mx plus b. Let's do this one for the red one. Here it is. Our b is where it crosses the y-axis. That's at 1. Let's find our slope. Okay, let's find 2 points. I can use these 2 points, or I could have used those two. Doesn't matter. Up 1 over 1, 2, 3. Up 1 over 3. Y is equal to 1/3 x plus 1. Okay. Now let's find the linear equation for the other one. For the blue one here. Y is equal to mx plus b. What's our b? It's where it crosses the y-axis, which is at what? From the origin, -1, 2, 3, 4, 5, 6. -6. And my slope's going to go from 1 to the other. I'm going up 1 over 1, 2, 3. 1/3. Look at this. Y is equal to 1/3 x minus 6. Notice, when there's no solution, they have the same slope, don't they? Parallel lines have the same slope. They just have a different y-intercept. If they're parallel, they have the same slope. Both of them are 1/3. They just have a different y-intercept. Huh? That means no solution. So if you're just looking at an equation and they both have the same slope, you know they're never going to intersect. There is no solution. Okay, now there's two lines on top of each other. See the dotted one and the whole one? What's their solution? Well, every point on here is common, isn't it? So there's an infinite number of solutions, right? Every point on those two lines. See, every point on here is on both lines, aren't they? All right, so there's an infinite number of solutions. Let's write the linear equation. Y is equal to mx plus b. Where does the line go through the b? Down here at negative 1, 2, 3, 4. What's the m? Let's see, rise over run. Let's see, where does it go through? Well, I know it goes through here. Let's try this one, okay? Down 1, 2, 3, 4, 5, 6, and over 1, 2, 3. Down 6 and over 3 is negative 2, isn't it? Y is equal to negative 2x minus 4. Well, what would be the equation for the other line? Well, it's exactly in the same place, isn't it? It crosses at negative 4. You'd use the same 2 points, rise over run, y is equal to negative 2x minus 4. If the equations have exactly the same solution, if the equations have exactly the same linear equation, then there's an infinite number of solutions because it's the same line, okay? All right. In your workbook, let's look at page 321. They've given us 2 equations and they've asked us to sketch the graph of these equations. Y is equal to 2/3 x plus 4. We know if we've got y is equal to mx plus b, we start at the b on the y-axis, so we start at the 4. Then where do I go? Our 2/3, our m, is equal to rise over run, over which is the same as change in y over change in x. From here, 2 over 3, I go up 2 and over 3, okay? And then you simply draw your line through the 2 points. There you go. Now let's do the other one. Let's plot the other one. Y is equal to 4/6 x minus 3. We start at the negative 3, that's our b. And then our rise over our run is 4/6. Up 4 over 6. Up 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6, okay? And let's draw that line. Well, look at there. We've got parallel lines, don't we? You're going, well, the slopes aren't the same. Well, what if I reduce 4/6? Would it be 2/3? Yes, it would. Okay, so they've got the same slope. Let's look at the questions that they ask us down here. Identify the slope of each equation. 2/3 and 4/6. Both of those are the m, right? But let's reduce 4/6 by 2 over 2, which gives me 2/3. What do you notice? Same slopes. Identify the y-intercept. Well, the y-intercept was 4 and negative 3, right? 4, negative 3. 4, negative 3. Are the y-intercepts the same or different? They're different. Is there a solution for the system? No. Why? Because they're parallel. They never intersect. Look, guys, if the slopes are the same, they're parallel, they have no solution. In your workbook, look at page 322. It says to plot these two. Okay, so when we've got y is equal to mx plus b, we start at our b. In this case, that's our 7. And our slope is negative 5, 4. So I got to go down 5. 1, 2, 3, 4, 5. And the positive direction 4. 1, 2, 3, 4. Make sure you understand that, guys, when you're dealing with a negative 5 fourths. It is not equal to negative 5 over negative 4, okay? That will not work. So when you go down 5, you have to go in the positive direction 4. Otherwise, you would be talking about positive over positive. Negative over negative is the same as a positive over positive. Okay, so now let's plot this line here. There's what that line looks like. And let's do the other one. It says we start at 2, and we're going down 5 and over 4. Look, the slopes are the same. What do you think is going to happen? You're going to have parallel lines, aren't you? 1, 2, 3, 4. Whoops. It was down one more. 1, 2, 3, 4, 5, and over 4. 1, 2, 3, 4. Okay. And I can plot this. And what do I have? Parallel lines, okay? If you have parallel lines, they're never going to intersect. Identify the slope of each equation. What do you notice? Our slope's negative 5/4 and negative 5/4. Negative 5/4, negative 5/4. They are the same, aren't they? Identify the y-intercept. What was the y-intercept? 7 and 2. See? 7 and 2. They are different. Okay? Is there a solution for this series of simultaneous or the system of equations? No. Why? They're parallel. They will never intersect. Okay? And on this one, let's sketch this one. This is page 323 in your workbook. We start at negative 5. Okay, start at negative 5, and our slope is 2. You got slope is 2. It's the same as 2 over 1. So I go up 2 and over 1, up 2 and over 1. Okay, and I can draw my linear equation. I can draw my line. Okay, now let's do the other one. My y-intercept is negative 1. My slope is 2. Up 2 and over 1, up 2 and over 1. Okay, so let's draw our line. Wow, look, they're parallel. If the slopes are the same, then the lines are going to be parallel. See, slopes were both 2. Identify the slope of each. It was 2. What do you notice? They're parallel. Identify the y-intercept. What do you notice? Let's see, the y-intercept was negative 1 and negative 5. These are different. These were the same. These are the y-intercepts different. Does this have a solution? No. Parallel lines never intersect. Okay, if they never intersect, there's no solution. Okay, now graph the following system of linear equations. Let's do this last one. Y is equal to 1/2 x plus 1. Start at 1, go up 1 and over 2. And there's that line. Then let's plot this other one. Well, it's kind of hard to plot that one, isn't it? Because when we look at that, we've got 2y's equal to this. What if we divide both sides by 2? I get y is equal to 1/2 x plus 1. Isn't that the exact same equation? So you start at 1, you go up 1 and over 2. We are talking about the exact same equation. These two are the same equation. They are on top of each other. Okay? There's an infinite number of solutions because every point on both those lines are going to be the same. How can you tell if a system of equations has no solutions? It's parallel, has the same slope. Okay? How can you tell it has the same slope? How can you tell if a system of equations has infinitely many solutions? Same linear equations. All right?